Hello, welcome to today's video. So as you know, I've got that Nissan Leaf battery pack that I need to pay off still. And around this time, we're a couple weeks out from Halloween, 3 weeks out from Halloween, and I get inundated with emails asking me to build animatronic tails for people. And if you look on my website, I have instructions and everything on how to build an animatronic tail, but yet I still get a bunch of people that can't do it themselves, and they're always asking me to do it for them. So my plan is to build a couple tails and put them up on eBay and auction them off and see if we get some money to help pay off that battery pack. So right here is a little section of leftover bit from an earlier animatronic tail, and it's just a Clicks toy here, which is this guy right here. It's like a little clicky thing, like you can scrunch it up and it does stuff. It doesn't really do anything. It's mainly, I stumbled upon this many years ago, actually about like 15 years ago, and it made a really good universal joint. It's like essentially a plastic universal joint, and that allowed, I was able to use that to make the spine for the very first tail. So this is what the full spine would look like. I take out those little clicky bits so you can see that these don't click, and put these little spanners across here, and that's to hold that. This is a bicycle brake cable, so it's just regular old-fashioned bike cable that you can get at any bike shop. I get the longest one they have. This is probably actually for tandem bikes. I'm assuming that's what that TB stands for, but I'm not quite sure. But yeah, that's what I ended up using. To make it move, take these 2-inch PVC end caps, the flat ones, and chuck that in the lathe and cut it across. So you end up with this, and just screw in the servo horn that comes with the servos, and you end up with something that looks like this. Well, here, I'll put it upside down so you can see it moving. Probably show it better on camera. But you just kind of attach the cables to it, and then the servo moves the tail back and forth. So it's really simple, not much going on. So push-pull cable system. You can move in all the axes. So what you essentially need is one like that and one like that to be able to handle that gives you your 2 axes of freedom. And those get bolted onto a bunch of servos here, using the high-tech high-speed. That's what the HS-5645MG, and HS is high-speed and the MG is metal gears. So this is a fully metal gear servo, which lets it put up with the fact that it's moving around a lot of mass pretty rapidly, especially if you hit things, but it'll be fine. So I've already built up the 4. We're going to build 2 tails. I'm going to try to do 1 canine tail and 1 feline tail. The only difference is length. The feline ones are longer, and they tend to run the program slower. Oh, speaking of program, there we go. They used to run on the old tail controller. This one, you can buy them on the website, and it's based off of ATmega Atmel. ATmega, what is that? 164p. Simple, drives 2 servos. One of the drawbacks to it is it takes these older 5-cell nickel metal hydride batteries, the old RC connector, and these are actually really expensive, and you have to have a separate charger and everything. So when I redid the new controller, so this one was designed back in 2005, so it's already 10 years old. So we've got the new one, the newer one here, which does a bunch more servos. Like this one only did 4, but it's a little bit bigger. But we're going to probably make this is the fully populated one. We won't need that. If you search for the real-time motion control system 2 on, RTMCS2 on my channel, you'll get an overview of what all this can do. But we're going to make a really basic one just for running the tails. But for power, I mean, you can still power it with the old-fashioned, with this connector. But what I'm planning on doing is we're not going to use these guys. So this doesn't have a label on it because it's an off-brand one, but you can see these are only 2,000 milliamp hour, and that would run it for quite a long time. But eventually the battery would die. But in the modern era, we now have lithium-ion power. So this is one of those power banks, or it's called pocket juice. One of those battery backup things to charge your cell phone with. And this guy is puts out 2.1 amps, 5 volts at 2.1 amps, and it does 4,000 milliamp hours. So it's actually twice the capacity of this, and just a little bit, it's a little thinner form factor, and a little bit bigger. But it's got an on-off switch on it, so that saves me. And it comes with this little dinky, tiny USB cable, which people are like, oh, that's probably really crappy, but actually works out really nice because I can do this. So I just happen to have this hooked up from there's a video where that's running. We can just plug that in, right? And then to turn it on, now it's running. So this is, I don't remember what's in here. I've got something. Tells you how much battery. You can click it again and it'll turn off the display. But then to turn it off, you just press and hold the button. Beautiful. And charge it up, you just use your standard cell phone charger. It's great. I like it. So we're going to incorporate this as the power supply for the tail, for the newer tails, for the ones I'm going to build. And I think that worked really good. We'll have the new controller, run the servos. Gosh, I think that's it. Oh, let me get this all out of here really quick here. For the main body of it, we just use this. Here, let me move all this stuff out of the way here. Shove that all up that way. We use this galvanized steel wire. This is the same stuff that they make chainmail out of. So I got a bunch of it here. But I don't remember the dimension of it here, but we can measure it. It is 0.625, it looks like. 0.63, depending where you measure it. So 60-ish thousandths. But that's what we'll make the frame out of, and I think what I'm going to do is like a time-lapse video of me building it. So essentially what we got to do is take these little servos with their big pulleys on them and mount them like so. So you end up with you know, the servo or the pulley is able to actuate the rest of it, and it's got to be held right angles from each other, and we're going to use this to do it. And hopefully I can crank those out, get them up on eBay and everything before Halloween, at least a week before, so that the auction can happen and there's time to ship them out to people who win. So that is the plan. And yeah, this is supposed to be a quick video and ended up taking a lot longer than it should. But anyways, that's I'll put some stuff out here. So, yes, that's what's going to happen. We're going to use this. We're going to use some servos. So one tail will consist of something like that. Anyways, thanks for watching.